Hello, Math for Liberal Arts. We're looking back at probability here. So the big thing we need to learn today are independent events and mutually exclusive events. So those are the two big vocabulary words to learn today. So on the screen, you'll see I have a Venn diagram from earlier in the semester. The first circle here is event A. The second circle, even though it's pretty ugly, is event B. In between here is event A and B. So what we're saying here is everything that belongs in event A, everything that belongs in event B, and the intersection here is things that belong in both. Okay. So first we'll talk about independent events. Independent events are when the probability is unaffected by the first event. Okay. So the independent events can be totally separate events. Like for instance, I could find the probability of rolling a 6 on a die, and I could find the probability of rolling a. Whoops, sorry. I could find the probability of getting a heads on the tails. So see how these two events are totally unrelated. So they're a good example of both mutually exclusive and independent. Okay, so what's going on here? If this is event A, if this is the first thing that I do, then the event A here is rolling the die, and I could get a 1, a 2, a 3, a 4, a 5, or a 6. So these are all the possible outcomes of event A. And here's event B and its possible outcomes of heads and tails. So you can see that these are independent events because when I roll the die, it has nothing to do with the coin, so it's not affecting the probability. Okay. We can see that they're also mutually exclusive because there is no overlap here. So since there's nothing in this section right here, we know they're mutually exclusive. They're totally different events. I can't be both at the same time. Okay. So let's look at another scenario. So we could also be doing the same thing over and over. So like let's say I want to draw a card, but I don't want to put the card back. Okay. So I want to know the probability of getting a king and then the probability of getting a king. Okay, so we got event A right here is the probability of getting a king. And in here we would have 52 cards. And of those 52, there are 4 kings, right? So this would be these are the possible outcomes that would be acceptable. Event B, though, if I don't put this card back, when I go to event B, things have changed a little bit. And now I can only count 3. And that's because one of these 52 has already been counted over here. Okay. So what you're seeing here is these are not independent events. If I draw a card and I don't put it back in the deck, then I do affect the probability of the next draw, and they're not independent. These are certainly not mutually exclusive because of this overlap, right? So when we get to the next lecture, you'll see how we're going to deal with this in mathematically. But for now, know that hey, it's not they're not mutually exclusive because you're drawing from the same deck. And a king, you could be a king of hearts, you could be a king of spades, so you could be either one. Okay, let's look at another situation. Some more, like we could be more, like we could say the probability of being a senior male and the probability of being the prom king, for instance. So in this one, we would have over here, we'd have like all the different males. So you could have seniors, you could have freshmen, you could have sophomores, you could have juniors. And over here, you could have like the king, you could have not king, you could have court, like whatever the other royalty is. Let's just say royalty. But the reality is there would be an overlap here where you could be a senior and the king because one of them is going to get to do that. So these are not mutually exclusive events. So when two events are not mutually exclusive, we have to take care of this intersect. Okay.